Hi, our talk is about enabling associativity for Gigascale DRAM caches by coordinating way install and weight prediction. This work was performed at Georgia Institute of Technology and with my collaborators Cha-Chen Cho, Amr Jalil, and Moinuddin Qureshi. As modern computer systems pack more and more cores on a processor chip, both the bandwidth and capacity of the memory system must also scale proportionally. Advancements in memory packaging and interconnect technology have enabled 3D stacked DRAM, which can offer 4 to 8 times bandwidth of conventional DIMM-based DRAM. However, while 3D DRAM provides higher bandwidth, 3D DRAM does not yet provide enough capacity to replace conventional memories. As such, an attractive organization is to architect 3D DRAM as a hardware-managed cache between L3 and main memory. However, there are many challenges associated with designing an effective gigascale DRAM cache. We can architect the cache at line granularity for high cache utilization. However, this needs significant tag storage. As such, practical designs must store these tags in DRAM. Now, how do we store and access these tags? One way is to store tag and data separately, but this would require 2 lookups per memory access, which is ineffective for bandwidth and latency. Instead, a more effective approach is to store a tag next to each data and organize the cache as direct mapped. One access retrieves both tag and data. This enables bandwidth efficient and low latency access. However, this organization becomes direct mapped and can have low hit rate. To this end, we propose Accord, a low-cost mechanism for enabling associativity while maintaining the latency and bandwidth benefits of a direct map cache. Thank you, and we hope to see you at our talk.